The signal traffic from Headquarters Middle East Command at Steamer Point, Aden, in the autumn of 1966 tells a particular story. Armoured car patrols of the Queen's Dragoon Guards, operating Saladin six-wheelers up the Dala Road toward the Radfan Mountains, were being engaged by Egyptian-supplied recoilless rifles at ranges where the Saladin's 76mm gun could elevate, but the vehicle itself could not maneuver off the metalled surface. The ground on either side of the road was loose shale and wadi bed. A 15-ton wheeled armoured car, however well armed, simply bogged or threw a tyre. Reports filed by Brigadier Richard Lloyd and forwarded to the Director Royal Armoured Corps at Bovington made the point in language that Whitehall could not ignore. The British Army was fighting a counterinsurgency with equipment designed for North German plain warfare. The same year, 3,000 miles to the east, the confrontation with Indonesia was winding down along the Sarawak border. Ferret scout cars of the 15th and 19th King's Royal Hussars had spent 3 years proving that a four-wheeled reconnaissance vehicle weighing 4.5 tons could not carry a gun heavier than a .30 caliber Browning, could not swim a river without elaborate preparation, and could not operate for more than 48 hours without the attentions of a REME fitter. General Sir Walter Walker, commanding Far East Land Forces, submitted a secret appreciation to the Chiefs of Staff Committee in March of that year. He wanted a tracked reconnaissance vehicle that could be loaded into a Hawker Siddeley Argosy, dropped into a jungle clearing, and fight on arrival. Bovington had been thinking along these lines since 1962. The Fighting Vehicles Research and Development Establishment at Chobham, under Dr. Gilbert Harvey, had been running quiet studies on tracked reconnaissance since the Suez debacle. The existing Alvis Saladin and Daimler Ferret families, both designed in the 1950s, had reached the end of their development potential. Cabinet office papers released under the 30-year rule show that the Defence Council, meeting at Storey's Gate on the 14th of November 1966, formally approved a programme designation for what was then called the Armoured Vehicle Reconnaissance Tract, or AVRT. The weight ceiling was set at 8 tons. The rationale, minuted by the Assistant Chief of the General Staff, was specific. 8 tons was the maximum disposable load for a Blackburn Beverley and later the Argosy, factoring in crew, fuel, and ammunition. It was also the load limit for the majority of wooden road bridges in Malaysia, Kenya, and the Arabian Peninsula. What the General Staff wanted, and what the Treasury was prepared to fund, was a vehicle that could do what the Saladin and Ferret could not. It had to swim without preparation. It had to mount a gun capable of defeating the Soviet PT-76 amphibious tank, which the Egyptians had deployed in the Six-Day War and which NATO intelligence assessed as the standard Warsaw Pact reconnaissance platform. It had to operate on petrol, because diesel was still considered a specialist fuel in tropical theatres. It had to have a silhouette under 2 meters. And critically, it had to be manufactured in Britain by a British firm, using British components. The import substitution requirement, buried in paragraph 14 of the General Staff specification, would prove decisive in the contract award that followed. The document that shaped everything was General Staff Requirement 3301, issued from the War Office on the 22nd of February 1967 and circulated to industry on a restricted basis 6 weeks later. The paper ran to 93 pages. A copy, declassified in the late 1990s and now held at the National Archives at Kew under reference WO 32-21447, reveals the precision with which the General Staff had thought through the problem. This was not a wish list. It was a technical specification written by officers who had commanded reconnaissance squadrons and knew what they needed. The primary role, stated in paragraph 2, was close reconnaissance in all theatres, by day and night, in support of armoured and infantry formations. The secondary roles included internal security operations, convoy escort, and airfield defence. The document specified a 4-man crew configuration for the gun vehicle and 3 for the supporting variants, because the General Staff had already decided that the AVRT would spawn a family rather than a single platform. Paragraph 7 listed the variants required. A gun vehicle mounting a weapon of not less than 75 millimetres, a command vehicle with enhanced radio fit, a recovery variant, an anti-tank guided weapon carrier, an ambulance, an engineer reconnaissance version, 9 variants in total, all to share a common hull and running gear. The weight ceiling was non-negotiable, 8,000 kilograms, combat loaded, with a margin of plus or minus 2%. Air portability was the driver. The specification demanded that 2 complete vehicles must fit within a single Argosy C Mark I fuselage, with a third to follow in a second sortie carrying crews and stores. The RAF Air Support Command, consulted in the drafting, insisted that the vehicle be drivable straight off the rear ramp within 60 seconds of touchdown. This meant no disassembly of components, no removal of fighting compartments, no folding turrets. Whatever emerged from Coventry had to roll off an aeroplane ready to fight. The mobility requirement was where the specification became genuinely remarkable. Paragraph 23 demanded a maximum road speed of not less than 80 km per hour, with a cross-country speed of 50 km per hour over undulating terrain. Ground pressure was to be less than 0.36 kilograms per square centimetre, which was lower than the average infantryman's boot. The rationale, explained in an annex, was that the vehicle had to be capable of operating across the soft going of the North German plain in the spring thaw, the paddy fields of Southeast Asia, and the sand of the Arabian deserts. The amphibious requirement called for swimming at not less than 6 kilometers per hour in still water, with preparation time not exceeding 2 minutes. Armament specifications in paragraph 31 required a gun capable of defeating armour equivalent to 60 millimeters of rolled homogeneous steel at 1,500 meters, with a secondary capability against soft-skin targets and infantry in the open. A coaxial general-purpose machine gun was mandatory. Night fighting capability using image intensification rather than infrared was specified as essential rather than desirable. This was a direct response to lessons from the Six-Day War, where Israeli crews had complained that active infrared systems revealed their positions to Arab observers. The document was circulated under a red top secret cover sheet to Alvis of Coventry, Vickers at Newcastle, GKN Sankey of Wellington, and the Royal Ordnance Factory at Leeds. Responses were required by the 1st of September 1967. The Alvis response arrived at the Ministry of Defence on the 29th of August 1967, 4 days ahead of the deadline. The firm had form. The Holyhead Road works in Coventry had produced the Saladin, the Saracen, and the Stalwart, and the engineering team under chief designer Edwin Galea had been working unofficially on a tracked reconnaissance concept since 1964. What Galea submitted was not a paper study, but a set of engineering drawings detailed enough that the Fighting Vehicles Research and Development Establishment could identify the component suppliers from the part numbers. The Vickers submission, from the Scotswood Works on the Tyne, offered a scaled-down version of the Vijayanta medium tank, then being produced under license for the Indian Army. At 9.4 tons, it exceeded the weight limit, and the Vickers team argued, not unreasonably, that the 8-ton ceiling was unrealistic given the armament demanded. The GKN Sankey proposal from Wellington in Shropshire was more imaginative, proposing a hull fabricated from a newly developed aluminium zinc magnesium alloy designated 7039. The Leeds submission from the Royal Ordnance Factory was withdrawn in October after the MOD procurement branch indicated that a state-owned factory bidding against private industry raised political difficulties. The evaluation board convened at the Military College of Science at Shrivenham on the 12th of November 1967. Under the chairmanship of Major General Simon Cooper, Director General Fighting Vehicles, the board sat for 4 days. Minutes of the proceedings, held at Kew under DEFE 70-845, record that the decisive moment came on the second day when the Alvis team, led by Galea himself, presented their proposed hull construction. Galea had adopted the aluminium alloy approach pioneered by GKN Sankey, but had gone further, proposing that the entire structural hull be fabricated from the same 7039 alloy, welded rather than riveted, using techniques developed by Alcan at Banbury. The weight saving over conventional rolled steel was approximately 40%. The penalty was cost, and the considerable difficulty of welding armoured aluminium without cracking the parent metal. What sold the board was the completeness of the Alvis technical proposal. Galea's team had already resolved the welding problem through a proprietary technique involving preheating and a specific filler rod composition developed in partnership with Alcan. They had costed the tooling, identified the suppliers, and proposed a production schedule that would deliver the first prototype within 18 months of contract award. The board recommended Alvis unanimously. The contract, designated FV4301 and valued initially at £2.8 million for development and 12 prototype vehicles, was signed at Main Building, Whitehall, on the 1st of May 1968. The first running prototype, designated P1, emerged from the Holyhead Road Assembly Hall on the 23rd of January 1969, 14 months after contract signature. It was painted in a dark bronze green and bore the registration plate 04SP72. Initial trials were conducted on the factory test track and at the Motor Industry Research Association grounds at Nuneaton. The vehicle weighed 7,850 kilograms combat loaded inside the specification. It achieved 82 kilometers per hour on the Mira high-speed circuit during its third week of trials. Galea, watching from the observation tower, was reported by the Coventry Evening Telegraph to have remarked only that the figure would improve once the suspension was properly bedded in. The name Scorpion was assigned in April 1969, continuing the Alvis tradition of naming fighting vehicles after venomous creatures. The engine that powered the Scorpion was already famous before it ever went to war. The Jaguar XK six-cylinder, designed by William Haynes and Walter Hassan in a bombed-out Coventry during the final years of the Second World War, had first appeared in the XK 120 sports car in 1948. By the mid-1960s, it had powered the D-Type to 5 victories at Le Mans and the Mark II saloon to the top of British police fleet registers. What Alvis required for the Scorpion was not the high-performance road car unit, but a detuned, militarised variant capable of running on the low-octane petrol available at forward refuelling points in West Germany, Malaysia, or the Gulf. The contract for the engine went to Jaguar Cars Limited at Browns Lane, Allesley, less than 3 miles from the Holyhead Road works. The militarised version was designated the Jaguar J60. It displaced 4,235 cubic centimetres and produced 190 brake horsepower at 4,700 revolutions per minute, running on 75-octane petrol. The compression ratio was lowered from 9:1 on the road engine to 7.75:1 on the J60, which sacrificed power for the ability to ingest the rough fuel that the Royal Army Service Corps could realistically deliver to a reconnaissance squadron operating from a forward harbour area. Fuel consumption, at approximately 1.2 kilometers per litre on roads, was poor by modern standards but entirely acceptable for a vehicle with a 480-litre fuel capacity and a required operational radius of 640 kilometers. The hull itself was the more radical achievement. The 7039 aluminium zinc magnesium alloy, supplied in rolled plate form by Alcan's Banbury Works, offered protection against small arms fire and shell splinters at a fraction of the weight of equivalent steel armour. The frontal arc was rated against 14.5 millimetre armour-piercing rounds at 200 metres, the standard threat from Soviet KPV heavy machine guns mounted on BTR personnel carriers. The sides and rear were proof against 7.62 millimetre ball at the same range. The armour was not thick by main battle tank standards. It varied from 12.7 millimetres on the hull sides to a maximum of 25 millimetres on the glacis plate. What mattered was that it was there at all within the 8-tonne weight budget. The welding was carried out at the Holyhead Road works by teams trained specifically for the work. The 7039 alloy was notoriously prone to stress corrosion, cracking along weld lines if the technique was wrong, and Alvis employed a proprietary procedure involving preheating to approximately 110 degrees Celsius and a filler rod of 5183 alloy composition. The finished hulls were heat-treated in a purpose-built furnace commissioned in 1970. Each hull took approximately 400 man-hours to weld and finish before it moved to the assembly line. Performance on trials was extraordinary for a tracked vehicle. The prototype achieved 87 kilometers per hour during high-speed runs at the Fighting Vehicles Research and Development Establishment track at Chertsey in the spring of 1970. This was fast enough that the Guinness Book of Records subsequently listed the Scorpion as the fastest production tracked armoured fighting vehicle in the world, a title it held until the advent of the American M1 Abrams in the 1980s. Cross-country performance was equally impressive. The low ground pressure, at 0.35 kilograms per square centimetre, allowed the Scorpion to cross ground where a Chieftain main battle tank would have sunk to its hull. The gun presented the design team with the most acute compromise of the entire programme. General Staff Requirement 3301 had called for a weapon capable of defeating 60 millimetres of rolled homogeneous armour at 1,500 metres, yet the recoil forces of any high-velocity anti-tank gun would have torn the aluminium hull apart. The 8-tonne weight limit forbade the hydraulic recoil systems fitted to heavier tanks. What the Royal Armament Research and Development Establishment at Fort Halstead in Kent proposed was a weapon of an entirely different philosophy. A low-pressure, rifled gun firing chemical energy rounds rather than kinetic energy penetrators. The L-23, a 176mm gun, was developed at Fort Halstead between 1967 and 1970 under the supervision of Dr. Sidney Edwards. It was based on the 76mm gun fitted to the Saladin armoured car, itself derived from the 17-pounder of the Second World War, but extensively modified for the tracked application. The barrel was 1.5 metres long, rifled with 24 grooves, and fitted with a pepper pot muzzle brake that reduced recoil forces to a level the aluminium hull could absorb. Chamber pressure at firing was approximately 2,400 bar, less than half that of a contemporary main battle tank gun. The entire weapon, including breech and recoil mechanism, weighed just 230 kilograms. The ammunition suite was where the design team made their real tactical argument. The primary anti-armour round was the L-29 high explosive squash head, known throughout the service as HESH. This was a round that the British had pioneered during the late 1940s and refined through the 1950s. It worked not by punching through armour, but by plastering a mass of plastic explosive against the target plate and detonating it with a base fuse, sending a shockwave through the armour that caused a scab of metal to detach from the inside face and ricochet around the crew compartment at lethal velocity. Against a Soviet PT-76 amphibious tank or a BMP-1 infantry fighting vehicle, the L-29 was decisive at ranges out to 2,000 meters. Against a T-54 or T-62 main battle tank, it could still disable the vehicle by rupturing internal components even when the armour itself was not penetrated. The secondary natures available in the 12-round ready rack included the L-32 smoke round, the L-40 canister for close-range work against infantry, and the L-33 illuminating round for night fighting. The canister round, which the Americans called flechette and the British called simply canister, contained several thousand steel darts dispersed by a small bursting charge at the muzzle. A single round could sweep clear a tree line at 300 meters. 2nd Troop, B Squadron, of the Blues and Royals would use this round to memorable effect on the slopes of Mount Harriet in June 1982. The fire control system was simple by modern standards, but effective for its era. The gunner used the Rank Precision Industries No. 44 by one image intensification sight, which provided passive night vision out to 800 meters without emitting detectable infrared radiation. The commander had an independent Sperry sight for target acquisition. The coaxial weapon was the L-37, a 7.62 millimetre general-purpose machine gun, a vehicle-mounted variant of the GPMG carried by the infantry. 3,000 rounds of coaxial ammunition were stowed within the turret. The turret itself, a compact two-man structure designed at the Royal Ordnance Factory at Leeds, rotated through 360 degrees in approximately 6 seconds on electric drive with manual backup. The amphibious trials were conducted in the summer of 1971 on the Instow beaches of North Devon, where the Royal Marines maintained an amphibious trials establishment overlooking the Tor and Torridge estuary. The Scorpion's flotation system was elegant in its simplicity. A canvas screen, stowed folded around the upper hull in a steel rail, could be erected by the crew in approximately 2 minutes. Once raised, it created sufficient freeboard to float the vehicle, which then propelled itself through the water by its own tracks at approximately 6.5 kilometers per hour. There were no propellers, no water jets, no fragile mechanical systems to fail in salt water. The commander steered by conventional track braking exactly as he would on land. The trials officer, Major David Chaundler of the Parachute Regiment on secondment to the Fighting Vehicles Research and Development Establishment, reported to Director General Fighting Vehicles on the 14th of September, 1971, that the vehicle had completed 47 water crossings, including 6 in Force 4 sea states without loss of buoyancy or ingress of water into the fighting compartment. The first production vehicles were accepted into service with the British Army of the Rhine in January 1972. The 17th for 21st Lancers at Wolfenbüttel were the first operational recipients, replacing their Saladin armoured cars in A and B squadrons during the first quarter of the year. The Lancers took their new mounts onto the Soltau training area in the Lüneburg Heath that spring and reported back to the Royal Armoured Corps Directorate at Bovington that the vehicle's performance exceeded the specification in every measurable respect, save fuel consumption. The regiment's war diary for April 1972 records a cross-country road march of 140 kilometres from Wolfenbüttel to the Bergenhone ranges completed at an average speed of 53 kilometres per hour, with no mechanical failures across a squadron of 16 vehicles. No previous British reconnaissance vehicle had come close to that reliability figure on first deployment. Cold weather trials followed in February 1973 at Bardufoss in northern Norway, where the Royal Marines of 45 Commando operated during their annual Arctic deployment. The Scorpions, drawn from the Household Cavalry Regiment's command reserve, were subjected to temperatures reaching minus 38 degrees Celsius. The Jaguar J60 engine, with appropriate winter-grade lubricants and a modified coolant specification approved by Alvis in January of that year, started reliably at minus 32 without preheating. The aluminium hull, contrary to some theoretical concerns raised by the Royal Engineers, showed no embrittlement at low temperatures. The rubber track pads, however, cracked extensively and had to be replaced with a neoprene compound developed by Dunlop at Birmingham for the production line from 1974 onwards. The hot weather trials at the British Army Training Unit Suffield in Alberta, conducted between June and August 1974, exposed a different set of problems. The Jaguar engine, running in ambient temperatures regularly exceeding 35 degrees Celsius on the prairie, suffered repeated cylinder head gasket failures during sustained high-speed running. Alvis responded with a modified cooling system incorporating a larger radiator and a higher capacity water pump, retrofitted to in-service vehicles from 1976 under Modification Instruction 114. Sand ingress proved more difficult to resolve. The air filtration system, designed for European conditions, required almost daily maintenance in desert operations. The lessons of Suffield would be paid for again, at a higher price, on the windswept moorlands of East Falkland 8 years later, where the combination of peat, water, and volcanic grit would test every assumption the designers had made. Task Force 317 sailed from Portsmouth on the 5th of April 1982 with 4 Scorpions and 4 Scimitars of 2nd Troop, B Squadron, the Blues and Royals, embarked aboard the landing ship Logistic Sir Lancelot. The troop leader was Lieutenant Lord Robin Innes Kerr, the 19-year-old younger brother of the Duke of Roxburgh, commissioned from Sandhurst less than 2 years earlier. His troop sergeant was Corporal of Horse Stuart Ferguson. The household cavalry contribution to Operation Corporate was, in strict military terms, tiny. 8 vehicles, 24 men. What they would achieve with those 8 vehicles over the following 10 weeks would rewrite every pre-war staff appreciation of what armour could do in the South Atlantic. The pre-war assessment, circulated within headquarters land forces at Wilton in the first week of April, had concluded that armoured vehicles could not operate effectively on East Falkland. The ground was peat bog interspersed with rock runs, cut by innumerable streams and saturated by the perpetual rain of the austral winter. Any tracked vehicle of normal configuration would sink to its hull within minutes of leaving the beaches. The Royal Marines Brigade staff at Plymouth had recommended against taking armour at all. It was Brigadier Julian Thompson, commanding 3 Commando Brigade, who overruled the advice, arguing that even a small force of reconnaissance vehicles would provide direct fire support that the lightly equipped infantry would otherwise lack. The vehicles came ashore at San Carlos Water in the early hours of the 21st of May. Their ground pressure, at 0.35 kilograms per square centimetre, proved lower than that of a fully equipped infantryman carrying his webbing and Bergen. Where the Royal Marines sank to their knees, the Scorpions floated across. The troop covered the ground from San Carlos to Estancia House, a distance of some 40 kilometres, without a single bogging incident. Lieutenant Inniscare's war diary, later deposited at the Household Cavalry Museum at Combermere Barracks, records that the limiting factor throughout the advance was not the vehicles but the fuel supply. The Scorpions drank petrol at a rate that taxed the Royal Corps of Transport's ability to deliver it across the boggy interior. The decisive engagement came on the night of the 13th and 14th of June on the slopes of Mount Tumbledown and Wireless Ridge. Two para, under Lieutenant Colonel David Chandler, who had commanded the Scorpion amphibious trials a decade earlier, were assaulting Wireless Ridge as the final blocking position before Stanley. The Blues and Royals troop, split into pairs, provided direct fire support from positions on Mount Longdon and the approaches to Wireless Ridge. Corporal of Horse Ferguson's vehicle, engaging Argentine bunkers at ranges between 600 and 800 metres, expended its entire load of 76mm ammunition in approximately 90 minutes of sustained firing. The L-29 HESH rounds, striking the turf-covered sangars built by the Argentine 5th Marine Infantry Battalion, proved devastating. Ferguson subsequently received the military medal for his conduct during the action. The troop lost no vehicles to enemy action. One scimitar struck an anti-tank mine on the approach to Stanley on the 14th of June, killing Lance Corporal Anthony Coe and wounding 2 other crewmen. It was the only combat loss from the entire Household Cavalry deployment. When the Argentine surrender was signed at Government House on the evening of the 14th, the 4 surviving Scorpions of 2nd Troop were among the first British vehicles to enter the capital, moving up Ross Road in the wet darkness. The decision to withdraw the Scorpion from British service was taken not for any failure of the vehicle, but for a failure of its ammunition supply chain. The Options for Change Defence Review, published by Secretary of State Tom King in July 1990, had already reduced the Royal Armoured Corps from 19 regiments to 8. The 76mm gun, with its specialist ammunition natures produced only at the Royal Ordnance Factory at Blackburn, was judged uneconomic to maintain for the smaller post-Cold War fleet. The Directorate of Land Service Ammunition at Andover recommended in February 1993 that production of the L-29 HESH round should cease by 1996, and that existing stocks should be consumed in training before that date. The Scorpion, without its primary armament, had no role. The replacement program, designated Sabre, was an interim solution devised at the Defence Research Agency at Chertsey in 1992. It consisted of a Scorpion hull mated to a Fox armoured car turret carrying the 30mm Raden cannon, a weapon firing the same ammunition as the Warrior infantry fighting vehicle and the Scimitar reconnaissance vehicle. 136 Sabres were converted at the Alvis Works at Coventry between 1993 and 1995. The last British Scorpion, registration 04FD97, was formally withdrawn from service with the Queen's Royal Hussars at Tidworth on the 15th of May 1994. The ceremony was attended by Edwin Galea, then 81 years old, who had flown down from Coventry for the occasion. He died the following year. The export story, however, was entirely different. Alvis had begun marketing the Scorpion abroad from 1973, and by the time British production ceased in 1994, the company had delivered more than 3,000 vehicles to 19 foreign armies. Belgium took 701. Iran, under the Shah, ordered 250, though delivery was curtailed by the revolution of 1979. Oman, Jordan, the Philippines, Nigeria, Malaysia, Brunei, Thailand, Ireland, Spain, Portugal, Chile, Venezuela, Indonesia, Tanzania, and New Zealand all operated the vehicle in one variant or another. The Belgian and Spanish vehicles saw service in the Balkans with United Nations forces during the 1990s. The Jordanian fleet, upgraded with Belgian Cockerill 90mm guns in the late 1990s, remained in frontline service into the 2020s. The Scimitar variant, mounting the 30mm Raden cannon rather than the 76mm gun, continued in British service long after the Scorpion had gone. Scimitars deployed to Kuwait with the 1st Armoured Division in 1991 and took part in the advance on Basra during Operation Granby. They returned to the Gulf in 2003 for Operation Telic and served in Helmand Province between 2006 and 2014 with the Household Cavalry, the Queen's Royal Hussars and the Light Dragoons, the final British scimitars upgraded to Mark II standard with a new Cummins diesel engine replacing the Jaguar petrol unit, were withdrawn from service only in April 2023. 54 years after the first Scorpion prototype had rolled out of the Holyhead Road works. Edwin Galea's design had outlived the Soviet Union, the Warsaw Pact, and most of the conflicts it had been built to fight. The Holyhead Road works itself closed in 2004, sold for housing development. A single preserved Scorpion stands outside the Tank Museum at Bovington, painted in the desert scheme of the 17th DOS 21st Lancers, a reminder of what British engineering could achieve when the specification was clear, the contract was honest, and the men who wrote both knew what reconnaissance actually meant.